There are two approaches people might be inclined to use when solving the inequality negative 3t plus 4 is greater than negative 5. Since many people are inclined to move the variables to the left side of an equation, they follow a similar process when solving an inequality. They will always move their variables to the left side of the inequality. That would be the first approach. Since this inequality has already been simplified, so there is at most one variable and one constant term on each side of the inequality, and all the variables are already on the left side of the inequality, I will begin by removing the plus 4 from the left side of the inequality. To cancel out adding 4, we need to subtract 4 from both sides of the inequality. When we simplify negative 3t plus 4 minus 4 on the left side, it becomes negative 3t. On the right side, negative 5 minus 4 is negative 9. And when we add or subtract, we do not adjust the inequality. To now eliminate the coefficient on the variable, to cancel out the fact that I'm multiplying by negative 3, I will divide each side of the inequality by negative 3. This is the one substantial difference between solving equations and solving inequalities. When you multiply or divide a linear inequality by a negative number, the inequality is reversed. So that greater than that had been between the negative 3t and negative 9 is now switched to a less than. And when we simplify each side of this inequality, on the left, negative 3t divided by negative 3 is t. Negative 9 divided by negative 3 is 3. The inequality is now going the opposite direction. We have now just solved this inequality for t, and know the t values have to be less than 3 to make that original inequality true. We'll solve this inequality again using a slightly different approach. Returning back to the original inequality, negative 3t plus 4 is greater than negative 5, some people would begin by recognizing the coefficient on the t is a negative 3. Not wanting to deal with multiplying or dividing by negative numbers, they would begin the process by adding 3t to both sides of the inequality. Again, addition and subtraction will not change the inequality's orientation, but it would leave us with this statement: 4 is greater than 3t minus 5. To finish solving this, we've now moved the variables to the right side of the inequality. We now want to remove the fact that we have a minus 5 on the right side. The opposite of subtracting 5 is adding 5. So we'll be sure to add 5 to both sides of the inequality. Simplifying on the left side, 4 plus 5 is 9. On the right side, 3t minus 5 plus 5 is 3t. And again, because we're doing addition and subtraction, the orientation of the inequality does not change. And so we're left with the statement 9 is greater than 3t. As a final step for solving, we need to again eliminate the coefficient on the variable. We are currently multiplying our t by 3, so to cancel that out, we need to divide both sides by 3. Because we are dividing by a positive 3, the inequality will not change. It'll stay a greater than symbol. Simplifying the left side, 9 divided by 3 is 3. On the right, 3t divided by 3 is t. And we're left with the statement 3 is greater than t. If we were to draw the first solution set that we had arrived at, t is less than 3, on a number line, we can begin by quickly sketching a number line, orienting ourselves by placing 0 on that number line, and placing 3 there. We would recognize that the t values we want are going to be less than, or to the left of, 3. And since it is not or equal to, we'd be oriented this way. We would exclude 3 as a potential solution, and we'd be highlighting or shading everywhere to the left. If we look at our second solution that we had come to, 3 is greater than t, we can recognize that this graph would be exactly the same graph that we already have. Saying that t must be less than 3 is in turn saying the same thing as 3 must be greater than the t values we pick. Either way, we need to be picking values that are to the left of 3. While both approaches are completely correct and will arrive at the same conclusion and the same solution set, people would typically be more inclined to use the first approach because it's more consistent with what we do with equations, moving the variables to the left side of the equation. Some people would choose to use the second approach because it avoids having to divide by a negative number. The downside of the second approach is the variable's on the opposite side from where we typically would want it to be. And in either situation, we definitely need to finish off with a conclusion. As we write this solution set in interval notation, the solution set on the left has no end. It goes forever. Since that's towards the negative side of the axis, we'll call that side negative infinity. The right end of the interval is at 3. So our solution set in interval notation is from negative infinity on the left, up to 3 on the right, We put a parenthesis on the negative infinity because it cannot be included, and a parenthesis also on the 3 because it is not included for this particular solution set. The solution set in set builder notation is the set of all t's such that t is less than 3.